All right, so we are going to talk about inscribed angles, and our goal is that we are going to be able to find the measure of an inscribed angle and use them to solve problems. So the first blank is an inscribed angle. Is an angle whose vertex is on a circle and whose sides contains chords of a circle. So just a quick little picture. It looks something like that. So if you recall with the other ones we were doing, it was always to the center it made the angle. With an inscribed angle, it's like the pink and it goes all the way to the opposite side of the circle. So then an intercepted arc consists of endpoints that lie on the sides of an inscribed angle and all the points on a circle in between it. So on my little sketch, it'd be that little space. And then a chord or arc subtends, oops, that was on the different pen, subtends an angle if its endpoints lie on the sides of the angle. So looking at this picture, again, DEF, the little red angle, is an inscribed angle. DF is the intercepted arc, and arc DF subtends DEF. So this subtends angle DEF. So our first theorem, and if you want the number, it is 12-4-1. The measure of an inscribed angle is half the measure of the intercepted arc. So if you notice with all of these cases, all of them have inscribed angles because all of the angles are on the side of a circle. So because of that, if you know your arc length, it's going to be half of that. Okay, so just a quick example of that. If this was, say, 60 degrees, then this one would be 30 degrees. Simple as that. So getting to the examples, finding the measure of angle PRU. PRU, P to R to U, we are looking at this arc right here and the angle down here. So because it's just half of the measure, it's going to be 118 because that's the arc measure divided by 2, which gives me 59 degrees. And that is literally all you have to do. So then if I wanted to find the measure of arc SP, SP is this right here, and we're looking at this angle measure now. So if it's half to go from arc to angle, if you're going angle to arc, you're going to double it. So it's going to be 27 times 2, which is 54 degrees. And if you want, you can even label that 54 degrees. Okay, so looking at example 2, you can go ahead and try it. If you want to pause the video, think you have it. But for angle DAE, D to A to E, we are looking at this arc, the 76 degrees. So we have 76 divided by 2 because the angle is half the arc, and that gives us 38 degrees. So then if I want the measure of arc ADC, we have to go A to D, to C. Oh, man. And if you notice with this, and I'm actually going to get rid of the purple so it's not quite so distracting, we are really looking at from this to this. And if you notice, if we follow these lines in, we are looking at a 135 degree angle. So remember, we are multiplying by 2 because we're going angle to arc. So multiply by 2, and that gives us 270 degrees. Okay, so just make sure if there's some distractions to you, just erase them, make it easier for you to see the angles, because it's really important that you can figure out that what angle corresponds to the arc that you are talking about. Okay, so moving on, we have a corollary, and if you want the number, it's 12-4-2. And it basically just says if an inscribed angle of a circle intercept the same arc or are subtended by the same chord or arc, then the angles are congruent. So if you look at all of these, the red lines all meet here, and so do the blue lines and the green lines. So even though all of those angles are at different spots, because they are making the same arc together in a way, then we know that all of the angles are congruent to each other. Okay? So that, what in the world? I don't know where that came from. Why is there a random pink on there? That's weird. So then the next theorem is 12-4-3. And an inscribed angle subtends a semicircle if and only if the angle is a right angle. So if you think about it, when you have a semicircle, that is like a diameter. And so if you have an angle that subtends that semicircle, that's going to be 180 divided by 2, which is 90 degrees. So remember, all these problems are doing with circles. It's going to be really helpful if you remember some of these rules about our angle measures so that we can solve it with right triangles and stuff. So looking at this, we want to find A. So because WY right here is a semicircle, I know that this angle has to be a right angle because the angle makes the semicircle. So all I have to do is set 90, because that's 90 degrees, equal to what they tell me. So 5A plus 20. So I would subtract the 20, and that gives us 70 equals 5A. And then when you divide by 5, you get that A equals 14. Okay? And again, that's just knowing that that makes a right angle. So now, if I want to find the measure of angle LJM, LJM is L to J to M, so it's just that little one. I kind of wish this was thinner. Oh, look, I can make it thinner. And then we also have, if you notice with this one, let me see if it makes it. That makes it a little better. Okay, so we have that angle, and then we also have this little angle over here. So because these two angles make the same little arc right here, yes, I'm using the fun pen, then I know that these two things are going to be equal to each other. So 5b minus 7 equals 3b. And then you're just solving. So I would add the 7 first. Or not add the 7. What am I doing? Ooh, forgot how to do algebra for a second. I would actually subtract the 5b first, because then you get the negative 7 by itself, and then you just have negative 7 equals negative 2b. So then when you divide by negative 2, the negatives cancel each other out, and you get that b is 3.5. Okay, so then, oopsie, didn't follow directions. We want to find what is LJM. So the measure, actually, let me change the color. The measure of angle LJM is going to be equal to 5b minus 7. So then we're going to have 5. B was 3.5 minus 7. And I do not actually have a calculator handy. So 5 times 3. Oh, this is annoying. I'm not good at mental math. So we're just going to do it the old-fashioned way because I have nothing better. 25. 5 times 3 is 15. 17. Throw that back in there. So we have 17.5 minus 7, which gives us 10.5 degrees. And again, this is the measure of angle LJM. Okay, so it is just a teensy little angle. So then, boop, going to find Z. Again, AC is a semicircle, and it is what makes up this angle. So because of that, we know it's a right angle. So then 90 equals 8Z minus 6. So then we're going to add the 6. We get 96 equals 8Z. And then divide by 8. And Z is 12. So unless they had asked us to find angle ABC, that is going to be your answer. So Z is just 12. So then for the measure of EDF, we are looking at E to D to F. And if you notice with this other angle, it is, even though off to the side, it's still making the same arc. So I know they're going to be equal to each other. So 2x plus 3 equals 75 minus 2x. So then when you solve this, I would add 2x to both sides. X. So that is 4x plus 3 equals 75. And then I would subtract the 3, and 4x equals 72. And when you divide by 4, you get that x equals 13. So then, because they want to know the actual measure of EDF, we're going to plug it into that 2x plus 3. So measure of angle EDF equals 2 times 13 plus 3. 2 times 13 is 26. So that would be 29 degrees for angle EDF. And my OCD is kicking in, so I'm going to write it up here too. Okay? Now, I did not write down the theorem number for this one, but I can almost guarantee it's 12-4- something. But if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So what that means is A and C will add up to be 180, and D and B will add up to be 180. And this is helpful because when you're solving it, you're going to get pictures like this, and you're going to have to do the work in order to find it. So what I did is I just started with angle G and angle J. And actually, I'm going to highlight this so it's a little bit easier. So J is this, G is this. So when you set it up, I know added together they are 180. So I'm going to have 3B plus 25 plus 6B plus 20. And notice I changed the color because I'm switching to the other angle. And that equals 180. So then you're just combining like terms. So that would give us, let's see, 3B plus 6B is 9B. 25 plus 20 is 45. So then to solve this, I would subtract 45. And then we'd have 9B equals 135. So when we divide by 9, boop, we get that B equals 15 degrees. So even though it's tempting to say, yay, I'm done, now you have to actually plug it in. And because we want to find the measure of each angle, we're going to plug it in for all of them. So we'd have 6 times 15 plus 20, which gives us 110 degrees. We then have 10 times 15 plus minus 69. And that gives us 81 degrees. And then we have, if we plug it into G, 3 times 15 plus 25. And that gives us 70 degrees. And then in order to find angle H, you just do 360 minus 81 minus 70 minus 110. And that gives you 99 degrees. So our actual angle measures, let's do purple. We have 81 for K, 110 for J, H is 99, and G is 70. Okay? So if we want to find the angle measures of this one, we're going to do the exact same thing, picking opposite angles. Draw. Why is it not reacting? There. Oh, it's thinking. Okay. So if you were to use L, notice there is nothing for J. So that doesn't help us. We kind of have to use K and M. So K and M, we would have 33 plus 6x plus M would be 4x minus 13. And that 6 looks funky. Equals, remember, they are supplementary, so it adds up to 180. When you combine your like terms, we would have 6x plus 4x is 10x, and then 33 minus 13 is 20. So then we subtract the 20. Boop. We get 10x equals 160, and then we divide by the 10, and that gives us x equals 16. So just like we did with the one before, we have to actually plug it in now. So we would have 4 times 16 minus 13, which would give us 51 degrees. For L, we would have 9 times 16 divided by 2, which would give us 72 degrees. Then if we do 33 plus 6 times 16, that gives us 129 degrees. Ooh. And then to find angle J, we just do 360 minus all of those, so minus 129 minus 51 minus 72, and that gives us 108 degrees. And actually, 108 degrees. That way it's easier. So then final answers, I kind of wish we had little lines duly noted for next year. We have angle J is 108, angle M is 51, L is 72, and J is 129. So you do have some homework in the book. It's listed at the bottom. If you have any questions, feel free to ask. But this is pretty much all that's going to be covered. So remember, just a quick recap. Remember, we have that quadrilaterals that are inscribed, the opposite angles are supplementary. We also have that if an inscribed angle makes the semicircle or a diameter, then you know that the inscribed angle is a 90-degree angle. You also know that inscribed angles, if they make the same chord, then all the angles are congruent. And then when you're finding the angle measures, remember that your angle is half the measure of the intercepted arc, or if you're given the angle, multiply it by 2. And that is 12.4.